Hi, my name is Emma Glass, and welcome to my presentation on the effect of decreased salinity on the filtration of Crassostrata virginica, the eastern oyster. Coastal communities are beginning to see the effects of sea level rise combined with storm surges, and the results are devastating, causing billions of dollars in flood damage annually. However, there is a new field of research just starting to emerge focusing on this new idea of hybrid infrastructure. This is the combination of man-made levees and seawalls with artificial wetlands and oyster beds. This will combat potential storm surge flooding in coastal communities. This idea of using natural and nature-based defenses as a mechanism for attenuating storm surge is just beginning, and there's much that still needs to be explored so that we can implement these systems to both be profitable and sustainable in the long run. I was specifically concerned about what would happen to the oysters used in artificial oyster beds for the purpose of storm attenuation. I specifically focused on young oysters because if an oyster bed is unable to thrive and continuously proliferate without losing the youngest generation in storm conditions, we could need to rethink just how to implement these oyster beds so they do indeed help to protect our shores, as well as be able to be strong and stable. The disease-resistant strain of the oysters used in this study were obtained from the University of Maryland's Horn Point Laboratory when they were 6 weeks old. I put about 300 oysters in each upweller at 15 parts per thousand salt water. The oysters were fed a diluted algae diet, and their water was replaced every other day. To mimic storm-like conditions, specifically in the Chesapeake Bay, I changed the salinities of the upwellers according to a USGS survey of salinities in the bay during flood conditions, normal conditions, and drought conditions. So the salinity that mimicked the flood condition was 9 parts per thousand, 15 parts per thousand was the control because that's what we had been growing them at, and 21 parts per thousand was also a normal condition in the bay. So 2 upwellers were placed in each salinity and allowed to incubate for 72 hours prior to my experimentation. Then, on the day of the experiment, the oysters were fed both the shellfish diet and live algae that we had been growing in the lab. So then, every 15 minutes for 6 hours, I would take samples out of these upwellers and read them with a vernier turbidity sensor, which output turbidity in NTU, a standard turbidity unit. So in order to compare the turbidities in the upwellers, each turbidity reading had to be normalized. So I would compute it as a percent of the initial turbidity, since each bucket started with a different initial turbidity. Then once I computed these values, I averaged the buckets of the same salinities to get this graph. So as you can see in this graph, the oysters in the 9 parts per thousand salinity did not filter the water as fast as those in the 15 and 21 parts per thousand. This is supported by my ANOVA test, or analysis of variance test, which resulted in a p-value of less than 0.01, which is very statistically significant. Then, to determine where my significance lied, I performed t-tests between the levels of the independent variable, which allowed me to see that there was statistical significance between the 9 and 15 levels as well as the 9 and 21 levels, as evidenced by the graph. So these findings show that if we were to use oysters in these artificial beds, we would have to be careful about using the young ones specifically, because if they were they're clearly not as healthy when they're in these decreased salinity environments during storm surges. So we would have to definitely do more research to see if these beds are able to be stable and proliferate into the future. So to continue my experiment, I would like to see maybe what would happen if I were to make the salinities more extreme, decreasing it below 9 parts per thousand and increasing it above 21 parts per thousand, as well as using the wild type strain of oysters in addition to these disease-resistant strain to compare how they react to these salinities. But overall, this is a very new field of hybrid infrastructure, so we definitely need to do more research and more in situ observations of these oysters and how they behave in the wild. So thank you very much.